In the last video, we saw that x to the negative n is equivalent to 1 over x to the n. Now, there are a number of different ways that this can be used and different contexts in which you'll see examples. So let me show you some variations on this theme. So another way of expressing the idea that x to the negative n is equal to 1 over x to the n is as follows. X to the negative n power over 1 is equal to 1 over x to the positive n. And this way, we see that when we have a term with a negative exponent in the numerator of a fraction, that is equivalent to having that numerator move down to the denominator with a positive exponent. And similarly, we can see that 1 over x to the negative n is the same thing as x to the n over 1. So these are two equivalent ways of saying that. Now there's a third variation that is not quite as obvious. It goes like this. If we have a fraction m over n to the negative a power, let's say, this is the same thing as n over m to the positive a power. So with these variations on the original theme, we can simplify just about any expression that we're going to see. So let's take a look at some examples, and I'll do exactly the examples in the handout. First of all, example number 1, simplify x to the negative 3. Well, that's pretty easy. That's just going to be 1 over x to the third. Next, let's take a look at this one. X over x to the negative 5. Now, we saw in the previous property that when we have something to a negative exponent in the denominator, that's equivalent to something to the same positive exponent in the numerator. So this would be equivalent to x times x to the fifth over 1, which is the same thing as, well, x times x to the fifth is x to the sixth, over 1 is just x to the sixth. Now here's an example where we have to do a little bit more work. We'll take x to the third, y to the negative 2, z, over x squared, z to the negative 4. Now, we learned that we can take a term in the numerator to a negative exponent and move it down to the denominator. So let's make that change. So this will be x to the third z, and then we'll move that y down here as a y squared times x squared times z to the negative fourth. Next, we have a negative exponent in the denominator that we can move up to the numerator. So this would be x to the third times z to the fourth over, and I'll just flip these around and put them in alphabetical order, x squared, y squared. Next, we can collapse z times z to the fourth, so that would be x to the third times z to the fifth over x squared, y squared. And finally, we have an x to the third divided by x to the second, and we can reduce that fraction to just an x z to the fifth over y squared. Okay, let's do another example. we will take, so this is example number 4, we'll take 3x to the negative 2, xy to the negative 3 over x to the negative 4 times 3x to the negative 2. Now here we have parentheses, we have negative exponents. There's a lot going on here. If we take things one at a time, one term at a time, then we can make this a bit simpler. So I'm going to do maybe a little more work than you might do if you were doing this by hand, by yourself, but I just like to show each step. So first, what we'll do is we'll take the terms, even within parentheses, and move them around so that all of the exponents are positive. So I'll work on x squared first. So the x to the negative 2 in the numerator can be moved down to the denominator. And let's move the x to the negative 4th from the denominator to the numerator. So this would be 3 times x to the negative 2 in the numerator is like x squared in the denominator. And then x to the negative 4 in the denominator is x to the 4th in the numerator. And then we'll just finish these out and do these in another step. Next, xy to the negative 3rd can be moved to the denominator by changing the exponent to a positive. And this can be moved to the numerator by doing the same thing. So this will be 3 x to the 4th, we'll leave the x squared there, and then xy to the negative 3 is equivalent to xy in the denominator to the 3rd power, and then 3x to the negative 2 is equivalent to 3x squared in the numerator. The next step is to expand. So we'll expand this to 3x to the 4th times 3 squared x squared, that's the numerator. The denominator, we have x squared times x cubed y cubed. So in this step, we expanded these parentheses and these parentheses. Next, we have 3 times 3 squared, that's 3 cubed, or 27. And then in the numerator, we have x to the 4th times x squared, that's x to the 6th. In the denominator, we have x squared times x cubed, that's x to the 5th, times y cubed. And then finally, we can reduce x to the 6th over x to the 5th to just x in the numerator. And that would be the final form. And let's do one more example. This will be 3xy to the negative 3rd to the 4th times 2x to the negative 2 y squared to the negative 3. Now here we have something that we haven't seen before. We have negative exponents inside parentheses as well as outside parentheses. And there are a couple of different ways of approaching this problem. I can show you one here. So the first thing is to, it's not a great word, but distribute the exponents in each. So this is going to be, the first one is going to be 3 to the 4th, x to the 4th, y to the negative 3 times 4, which is negative 12, times 2 to the negative 3, x to the negative 2 times negative 3, which is x to the 6th, and y to the 2 times negative 3, or negative 6. Next, we can move each of the terms to its proper place. So this is going to be a fraction. So we're going to have 3 to the 4th times x to the 4th, y to the negative 12th will be in the denominator as y to the 12th. 2 to the negative 3 will be in the denominator as 2 to the 3rd. X to the 6th will stay in the numerator, and y to the negative 6th will come down to the denominator as y to the 6th. So we'll do a little more work here. 3 to the 4th is 81. X to the 4th times x to the 6th is x to the 10th. And in the denominator, 2 to the 3rd is 8. And y to the 12th times y to the 6th is y to the 18th. Now, in more complicated expressions, you may have to expand parentheses like this first, move some terms around, and perhaps do that again. So I hope this gives you a little better understanding of how to apply the properties of exponents and as to how to simplify even the most complicated expressions. Good luck.